Hello and good morning. We are from the group 7. So we present about the part A, application of a differentiation for our function fx equal to 1 over 3 x cubed plus 1 over 2 x squared minus 6x plus 8. For the first question A, critical number of the function. First, we differentiate the function. Next, we find the critical number by setting the first derivatives equal to 0. So the critical number are x equal to 2 and x equal to minus 3. For the question next, B, to identify whether these critical points are maximum or minimum, we use the second derivative test, which first find the second derivative, which is f double prime x equal to 2x plus 1, and substitute the critical point we get from the A. And for x equal to 2, we will get 5, which is greater than 0. The function has a relative minimum at the x equal to 2. And for x equal to minus 3, we will get negative 5, which is less than 0. Since it's less than 0, the function has a relative maximum at the x equal to minus 3. For the question C, the interval on which fx is increasing and decreasing. First, we will using the first derivative for this question. We will take 3 interval using our critical point we get from the A. So the interval is negative infinity to the negative 3, and the test number I use is negative 4, and I will get 6, which is positive and it is increasing. For the second interval, negative 3 to 2, I choose 0 as a test number, and I get negative 6, and it is negative and decreasing. For the last interval, to 2 to the positive infinity, I choose 3 as a test number, and sign of the f prime, which is the positive, and it increasing.
Plot the graph using the GeoGebra. The graph represents the function fx 1 over 3 x to the power of 3 plus 1 over 2 x to the power of 2 minus 6x plus 8, plotted using GeoGebra. From the graph, there are 2 critical points at x equal to negative 3 and x equal to 2, where the slope of the tangent is 0. At x equal to negative 3, the graph reaches a relative maximum as the curve changes from increasing to decreasing. At x equal to 2, the graph reaches a relative minimum as the curve changes from decreasing to increasing. The graph is increasing on the interval negative infinity to 3, negative 3, and 2 to infinity, decreasing on the interval negative 3 to 2.
In question 2, 2 parallel sides of a rectangle are being lengthened at the rate of 2 inches per second, while the other 2 sides are shortened in such a way that the figure remains a rectangle with a constant area A equals to 50 inch squared. What is the rate of the change of parameter P when the length of the increasing side is 5 inches, 10 inches, and what are the dimensions when the parameter is to decrease? So what this question tell us that when the length is increasing, the y must be decreased so that the equal area will always remain 50 inch squared. So in these equations, we know that area is equals to length multiplied by width. We know that is also equals to 50 inch squared. So what we must do is that we need to differentiate the equation. By using the product rule, we will get that L multiplied by dw dt plus w multiplied dl dt equals to 0, because when constant is differentiate, it will always remain 0. Now that we need to leave behind the dw dt and move the others to the other side, and we will get these equations. since we know that area is equals to length multiplied by width, we will get that width is also equal to 50 over length. And we know that the rate of length increase by 2. By having these two information, we can just substitute the number into the equations, and we will get the equations dw over dt equals to negative hundreds over L squared. Now we know that they are asking us what is the rate change of the perimeter. So what we must do is that we need to also find the equation for the perimeter. We know that the perimeter is equals to 2 length plus 2 width. Then we need to differentiate it, and we will get dp over dt equals to 2 dl over dt plus 2 dw dt. We also know that dl dt is equals to the increase of length is 2, and we also know that dw dt by the previous equation we get. So what we must do is just substitute the equation into this perimeter equation, and we will get that dp over dt is equals to 4 minus 200 over L squared. Now from the questions, they ask us what is the rate of change of the perimeter P when the length of the increasing side is 5 inches. So just put the length equals to 5 into our final equations. By dp over dt equals to 4 minus 200 over 25, we get that dp over dt is equals to negative 4 inch per second. So for B we get they ask us what is the rate of change of perimeter P when the length of the increasing side is 10 inches. So just put the 10 substitute the L with 10, we get that dp over dt equals to 4 minus 200 over 100. We get that dp over dt is positive 2 inch per second. For C, they ask us what are the dimensions when the perimeter ceases to decrease. What this means that dp over dt is equal to 0. So just substitute the 0 into dp over dt equations. We get that 4 minus 200 over L2 equals to 0. Then we move the equations. We get that 4 equals to 200 over L squared. By moving the L squared, we get that 4L squared equals to 100, and we get that L squared equals to 50, and we get that L is equal to 5 sets 2, which lead to W equals to 50 over L equals to 50 over 5 set 2 equals to 10 over set 2, which is also 5 set 2. So we get that L is equal to W equals to 5 over 2 inch. This means that the rectangle becomes a square.
Okay, so the question is the total cost of producing S-shaded sets per day is RM in the bracket 1 over 4 x power of 2 plus 35x plus 25, and the price per set at which they may be sold at is RM 50 minus 1 over 2 x. So question A asks what should be daily output to obtain a maximum total profit. So first of all, we conclude that Cx, which is cost for the radial sets, is 1 over 4 x squared plus 35x plus 25. So that's why I wrote Cx. And then the Px is actually the price per set. So we conclude that Px is equal to 50 minus 1 over 2x. So by the formula, which is fx equal to x and px, so we can say that the r the Rx, which is the rate, is equal to X times Px. Px which is the price. So after that we just times X times 50 minus 1 over 2x. And the answer we got is 50x minus 1 over 2 x squared. So in order to obtain the profit, so firstly we must set that profit is equal to Px. So the profit formula is by, we're back again at how to find the profit. So first of all, why we conclude that Px is equal to Rx minus Cx is because Rx is revenue. So revenue must minus the cost to get how much the profit. So we just show the equation here, which is 50x minus 1 over 2x squared minus bracket 1 over 4x squared plus 35x plus 25. And lastly, the answer is 15x minus 3 over 4x squared minus 25. So in order to know the maximum daily output, so we must firstly find the first derivative. So we just differentiate the Px and we get 15 minus 3 over 2x. Since the first derivative is equal to 0, so we conclude that 15 minus 3 over 2x is equal to 0. And after that, we just solve how to get x. And the answer is maximum daily output is 10. Okay, back to the question for question C. Question C is show that the cost of producing a set is a relative minimum at net output. So to show that the cost of producing a set is a relative minimum at the output found in part A, which is 10, we first define the average cost function. So the total cost of producing X radio sets per day is given by Cx equal to 1 over 4x squared plus 35x plus plus 25. So we conclude that the cost per set average cost is obtained by dividing the total cost by the number of units produced. So we conclude Kx is equal to Cx over x. So after that, we just derive it. So the answer we may get is 1 over 4x plus 35 plus 25 over x. So the next step is we must differentiate the average cost function with respect to x. So we just put the 1 over 4 minus 25 over x squared. That is the answer we get after we differentiate it. And we equal it to 0 because we want to find the x. So after that, we get the x equal to 10, which is the same number of what we get in part A. But we must use the second derivative test. We must use the second derivative test to determine the nature of the stationary point. So first of all, we just differentiate again the kx. So we get the 50 over x cubed. So we include the x equal to 10 into the equation and we get 50 over 1000. So which is 50 over 1000 is more than 0. If anything is more than 0, it is a minimum. So in conclusion, the output that maximize the total profit also minimize the cost per unit. Hence, producing 10 radio set per day is the most economically efficient level of production.
We move to the question number 4, which is for 1 and for 2. So the question is show that limit x approaching 0, sine 3x over 4x. By using L'Hopital rule, what is L'Hopital rule? L'Hopital rule is a method in calculus used to evaluate limit that give intermediate form. So we need to differentiate this sine 3x over 4x. So it will produce 3 cos 3x over 4. And then substitute the value of x, which is 0. which is 0, into the formula equation, and then we will get the answer 3/4 for the first question. Now we move to the 4.2, which is limit n approaching infinity 3 exponent power of 2n over 4n square, which by using L'Hopital rule, it will give a positive infinity answer. This is because 2n approaching infinity, which is exponential power of 2n, becomes extremely large. After multiplying by 3, it still gives infinitely large value. Hence, the expression is growth without limit. Therefore, the final answer is the positive infinity. That's all.
For question 4, Roman 3, as we can see, as x approach 0, ln x will become negative infinity and x square will become 0. So the expression will become 0 times negative infinity, which is an indeterminate form. So we need to rewrite the expression as a fraction form. So after change the expression into a fraction form, we will get this expression, ln x over x to the power of negative 2. As we can see, as x approach 0, the numerator will becomes negative infinity and the denominator will becomes positive infinity. So this give the indeterminate form, which is negative infinity over positive infinity. So L'Hopital's rule can be applied. So after apply L'Hopital's rule, we can differentiate this expression. So we will get 1 over x over negative 2 x to the power of negative 3. And we can simplify this expression by cancelling the x. So we will get x squared over negative 2. So the answer will be 0. Question for Roman 4. As you guys can see, as n approaches infinity, n goes to infinity, and e to the power of 2n also goes to infinity. So the exponential function grows much faster than a linear function. Since both factors increase without bound, their product also increase without bound. So the expression is growth without a limit.